Hello everybody, this is Miss Maneely, and I'm going to give you a quick tutorial on how to solve systems involving two variables using three different methods. We're going to graph, we're going to use a substitution method, and then I'm also going to show you a method called elimination. Let's first start with graphing. You guys are probably familiar with graphing lines, and so we're going to start with an example where both equations are in slope-intercept form. So I'm going to graph by hand. If you remember, we always want to start with the y-intercept. So I'm going to graph my first equation, y equals negative x plus 3. And I'm going to find 3 on my coordinate plane, and I'm going to plot it. Then the negative 1, or the negative x, implies that the slope is negative 1. And if my slope, m, is equal to negative 1, then I can put a 1 underneath it, and the number on top becomes my rise. The number on the bottom becomes my run, if you've done this by hand. So from my y-intercept, I'm going to go down 1 and forward 1 and plot another point. And I can continue doing that and following the same pattern. And that enables me to kind of get a good idea of where this line is going to be. And then with your ruler, and you do want to be pretty precise when you're graphing these, you want to go ahead and draw your line. And you want it to be as close to exact as possible because we're essentially looking to see where the two lines intersect. So that's the first equation. The second equation, I have a y-intercept at negative 2. And my slope now is positive 3 over 2. That means from negative 2, I'm going to rise 3 and run 2. So right now, I can see exactly where my two lines are going to cross. And so to go ahead and solve the system, I know that the point of intersection is going to be where the two graphs intersect. It's also going to be the solution to my system. And so we always report the x value first. So in this case, x is 2 and the y coordinate is 1. You can also graph systems on your calculator. If you go into the y equals menu, if you have anything in there, just go ahead and clear it out. And I can go ahead and type in negative x plus 3 as my first equation. I can do 3 halves. Make sure whenever you're entering fractions into the calculator that you put them in parentheses, then type in my x minus 2. And I'm going to go ahead and graph this on a standard window. So if you go to your zoom menu, option 6 is your standard window, and that will give you a window that goes from negative 10 to positive 10 on both the x and y axis. So you can see that it looks pretty similar to what I plotted by hand. And if I want the calculator to find the intersection point, I'm just going to go to second trace, and you'll see that option 5 is the intersection. Since there's only one intersection for these two lines, if I just press enter 3 times, and you'll see the calculator is prompting me, I will also see that the intersection is 2, 1. Now sometimes your equations aren't in slope-intercept form. If we take a look at example number 2, we've got two equations that are not in slope-intercept form. So if I'm going to use the graphic method, it really is helpful to rewrite both of those equations so that they're solved for y. So the first equation, if I have 2x minus 2y, is equal to 4. I want to get y by itself. So the first thing I'm going to do is subtract 2x from both sides. And so that leaves me with a negative 2y because my x's are now canceled. And I can't combine the 4 and the negative 2x into one term, so I'm going to leave it as negative 2x and a positive 4. The last step would be to get y by itself. I'm going to need to divide by negative 2. And just make sure with multiplication and division that you always distribute. So if I'm going to divide the y by negative 2, every single term in the equation gets divided by negative 2. So this equation becomes y equals negative 2 divided by itself is just going to be 1. So I'm going to have x, and then 4 divided by negative 2 is going to give me minus 2. And so my equation becomes y equals x minus 2. So my y-intercept is at negative 2. My slope is 1. So if I rise 1 and run 1, I can go ahead and draw my line. And I might want to extend that just a little bit further. There we go. And then with the second equation, we have y minus x is equal to 6. And again, we're trying to get y by itself. The easiest thing to do now is just add x to both sides. That way those x's cancel, and I'm left with y is equal to x plus 6. So this time my y-intercept is at positive 6, and my slope is the same as it was before. And what you may know is if two lines have the same slope, then they are considered parallel lines. That did not work very well. Let me fix that. And two parallel lines do not ever intersect. And so one of the things that you'll notice about this, if we have parallel lines, we know they don't intersect. And that means there's no solution. Okay. What you might also hear is that a system that has no solution is often called inconsistent. That's another name for it. Okay, and we could also try graphing that on the calculator. If you go to try to do the intersect option, it's just going to give you an error message. Okay, the second method that we use for solving is called substitution. And substitution is really helpful when you have one of the variables already isolated. So it's helpful if your equations aren't in the same form. So if you take a look at number 3, notice that we have our first equation is in standard form, ax plus by equals c. And then our second equation actually isn't in any of our common forms, since it's x equals negative 2y plus 2. But that's okay. If I use the substitution method, because I already have an expression that is equal to one of my variables, I can actually take that expression and substitute it in for the variable in the other equation. So I've got the steps listed. It says to solve one equation for one of its variables, and this will be what we would call the revised equation. So if you take a look, my first step is already done for me because I already have x by itself. The second step then would be to take that expression and plug it into the other equation and solve for the other variable. So since this quantity, negative 2y plus 2, is equivalent to x, what I'm going to do is I'm going to substitute it in for x in the other equation. And so my first equation was, and this is how I usually do it, I kind of just put parentheses to hold my spot. So the first equation was 3 times some quantity x plus 4y, and that's equal to negative 4. But I'm not going to put in the x, I'm going to put in the other quantity from the second equation, which is negative 2y plus 2. And now notice I have one equation and it only has one variable. And that's fabulous because that means that I can get that one variable by itself and have part of my solution. So in order to solve this equation, I have to follow the order of operations. And so I've got parentheses, which I'd need to deal with first. I can't simplify what's inside of them, so the next step would be to deal with the multiplication, and I want to distribute that 3 to both terms. And I'm only distributing the 3 to the terms inside the parentheses. So 3 times negative 2y gives me negative 6y, and 3 times a positive 2 is going to give me a positive 6. I still have a plus 4y and an equals 4 to complete my equation. The next step would be to combine my like terms. So I've got a negative 6y and a positive 4y. When I put them together, I get a negative 2y. I'm going to bring down the 6, and that still is equal to 4. The goal is to get y by itself, and so when you're thinking about your order of operations, typically we take care of the multiplication first and then the addition. However, when you're solving an equation, you want to go in the reverse order. So I'm going to undo my addition first by subtracting 6 from both sides, and that's going to leave me with a negative 2y equals a negative 2. And now finally, I can divide both sides by negative 2. And remember, with multiplication and division, you're not changing the signs. So I'm almost there. I've now determined that the value of y is equivalent to 1. My last step now is to take that value of y, and I can plug it into either of the original equations to solve for x. Now I will say, in the second equation, x is already isolated. So that's the equation that I would recommend using. So since I already know that x is equal to negative 2 times y, and I'm just going to put parentheses there to hold its spot, and I've got a plus 2. And so now, since I know that y is equal to 1, I'm going to go ahead and plug that in and then simplify my expression. So negative 2 times 1 is just negative 2. And if I add 2 to that, I get that x is equal to 0. And so when you write your answer, we usually write it as an ordered pair because if you remember from the graphing, it's just the solution to a system is just a point on the graph where the two lines intersect. So we list our x value first and then our y. In number 4, it's not quite as easy because we don't have an equation where x or y is already isolated. So what I want to do is I want to look for the term that would be the easiest to get by itself. And the first thing I notice is that this x has a coefficient of 1. That's going to be the easiest thing to get by itself because all I have to do is add 2y to both sides. I don't have to multiply or divide to get x by itself. So that's the first thing I'm going to do. I'm going to take my equation, x minus 2y equals 4, and I'm going to go ahead and get x by itself by adding 2y to both sides. And when I do that, I get that x is equal to 2y plus 4. Remember, I can't add unlike terms. So now that I have this expression that is equivalent to x, I'm going to plug that in for x into the other equation. So the other equation was 3 times x, or something. I'm just going to leave parentheses there for now. And then I'm going to finish writing the rest of the equation. Plus 6y equals 6. And now instead of writing the x, I'm going to type in or write in 2y plus 4. I'm substituting it in. That's why this is called the substitution method. And then I'm going to follow my order of operations and simplify the expression. So this is going to give me a 6y. That's going to give me a plus 12. I have another 6y, and that is equal to 6. Combine your like terms. 6y plus 6y gives you 12y. Plus 12 is equal to 6. If I subtract 12 from both sides, I get that 12y is equal to negative 6. And finally, dividing by 12, y is going to equal, well, negative 6/12 is just negative 0.5, or negative 1/2. So now I have a value for y. I have a solution for my y variable. And so the next step is to take this expression and plug it into one of the equations. And just like before, it's going to be easiest to plug it back in to that first, what we called the revised first equation, because x is already isolated. And so I'm going to do that over here. I'm running out of space. But if I have x is equal to 2 times y plus 4, all I'm going to do now is plug in what I had was negative 0.5 for my y value. And if you think about it, 2 times negative 0.5, I'm just taking half of 2, and because it's negative, I'm going to end up with a negative 1 plus 4. And then when I finish solving, I get that x is equal to 3. And so the solution here is going to be 3 and then negative 0.5. And that's how you use the substitution method. It's always a good idea, too, to plug your answers back in and make sure they work. So let me just show you how to do, how to check your answers using the last problem that I just did. So we figured out that x is 3, and then I want to do minus 2, and then all I'm doing is plugging in the values of x and y in that first equation, and then we determine that the value of y is negative 0.5. And when I press equals, it should equal 4, and it does. For the second equation, I'm going to take 3 times 3, which is my x value, plus 6 times my y value, which we said is negative 0.5. And when I press enter, it should be 6. And it is. So I know I saw this system correctly. The last method is what we call the linear combination method. And this is probably everybody's favorite method. It works best when equations are written in standard form and your x's and y's are lined up. Remember, we don't always have to use the variables x and y, but it certainly does help when you're dealing with the same variables. So with the elimination method, basically what it's saying is, you know, if I have an equation, as long as I'm adding the same thing to both sides, I can combine them. And so if I take a look at number 5, if you look at this equation, at this system right off the bat, everything's lined up. My x's are lined up, my y's are lined up, my equal sign is lined up, everything's lined up. If I were to add these two equations together, then I'm going to find 11x minus 6x, or 11x plus a negative 6x, is going to leave me with 5x. Notice that my y's cancel. I have a positive 7y and a negative 7y, so they cancel. And then I've got 9 and a negative 24, which is going to leave me with a negative, where am I? 15. And so if I've got 5x and that is equal to negative 15, notice now I've reduced the system of equations into one equation with one variable, and if I divide both sides by 5, I find out very quickly that x is equal to negative 3. And now I'm going to go back and do what I did with the substitution method. Once I know one of the variables, I can go ahead and plug it in, and it doesn't matter which equation I choose. I can solve for the other variable. So let's go ahead and plug it into the first equation. The first equation was 11 times x, I'm going to put that in parentheses, plus 7y is equal to 9. And so what I want to do is I want to replace the x with the 3. 11 times 3 is 33. And I still have the plus 7y, and that equals 9. If I subtract 33 from both sides, we get a negative 24. And if I divide both sides by 7, notice in this case I'm not going to get a whole number. That's okay. So we find that y is equal to a negative 24 sevenths. If I want to now check my answers, and I hope this works, I feel like I might have made a mistake somewhere. So if I want to check my answers and make sure I'm correct, I need to check the solution in both equations. So I'm going to take 11 times, we said the x value is negative 3, plus 7 times my y value, which we said is negative 24 divided by 7. Make sure you put that in parentheses. And hopefully when I press enter, I did something wrong. I see what I did. X is supposed to be a negative 3. So this is actually a really good learning point because I only realized that I made a mistake when I checked my work. So we got to go back through and fix it. All right, so if I kind of come back in here and adjust this part. All right, so 11 times a negative 3 is going to give me a negative 33 plus 7y is equal to 9. And so I'm actually adding 33 to both sides. And so we get a 7y is equal to 42. And there we go. If we divide both sides by 7, we get that y is equal to 6. And this should work. So let's just double check. So if I've got 11 times my x value, which was negative 3, and then plus 7 times 6, there we go, I get 9. And then I also want to double check it in the second equation because it's possible it could work in the first and not in the second. So we got negative 6 times negative 3 minus 7 times 6. And hopefully that'll give me negative 24, and it does. Okay, so just another reason to always check your answers to make sure you haven't made a silly mistake like I did. All right, in number 6, this is a little bit different because if I add the two equations the way they are written, nothing cancels. If I add them together, I'm going to get 6x plus 4x is going to give me a 10x. Y and a negative 3y is going to leave me with a negative 2y, and then I'm going to have a negative 12 on the other side. So then I'd only have one equation with two variables, and there'd be no way to solve for x or y. So the goal is to transform one of the equations, or possibly both, so that one of my variables will cancel. And it doesn't matter which variable you choose to cancel. I'm going to notice that my y variable, because I have a y that has a coefficient of 1, that's going to be the easiest thing to cancel. And so what I'd like it to be is a positive 3, so that when I add it together with a negative 3, they both cancel. So what I'm essentially going to do is I'm going to multiply this side of my equation by negative 3, and I'm going to multiply the other side of the equation by negative 3, because as long as I multiply both sides by the same thing, I've kept the equation balanced. So let's go ahead and multiply through. This first equation now becomes a negative 18x minus 3y, and it's going to equal a positive 15. And so now I'm going to combine those two equations. And when I do that, I made another mistake. They don't cancel, do they? So what I want to do is adjust this so it's a positive 3. I'm not on my game right now. And change all the signs. And now when I combine them, my 3y's will cancel. And I'm going to have a 4x plus 18x, which is going to give me a 22x. The y's are going to cancel, and negative 7 and a negative 15, when I put them together, gives me a negative 22. When I divide both sides by 22, I get that x is equal to negative 1. And now that I have x, I can plug it into either equation. I'll just go ahead and plug it into the first one. So we had 6 times x, I'm just going to leave it in parentheses for a second, plus y is equal to negative 5. And if I replace my x with a negative 1, I get negative 6 plus y is equal to negative 5. If I add 6 to both sides, I get that y is equal to 1. And so my solution now is negative 1, 1. And if we want to double check, because I'm sure you're losing confidence in me, we'll do 6 times negative 1 plus 1, because that's my y. And when I press enter, I should hopefully get negative 5, and I do. 4 times negative 1 minus 3 times a positive 1. 4 times okay. Okay, and I get -7, and so that works as well. And so there's my solution. All right, you have several practice problems using all 3 methods. Good luck!